Now, if you solve, so let's look at the equation in this form will be good enough, the y prime. When you solve it, let me remind you that how the solutions look, because that explains the terminology. The solution looks like, after you've done the integrating factor and multiplied through and integrated both sides, you know, in short, what you're supposed to do. The solution looks like y equals, there's the term e to the negative k out front times an integral which you can either make definite or indefinite according to your preference. Q of t times e to the kt inside dt. It will help you to remember the opposite signs if you think that when q is a constant, 1 for example, you want these two guys to cancel out and produce a constant solution. That's a good way to remember that the signs have to be opposite. But I don't encourage you to remember the formula at all. It's just a convenient thing to be able to, for me to be able to use right now. And then there's the other term which comes by putting out the arbitrary constant explicitly, c e to the negative k, t. So you can either write it this way, where this is somewhat vague, or you can make it definite by putting a 0 here and a t there and change the dummy variable inside according to the way the notes tell you to do it. Now, when you do this, and if k is positive, that's absolutely essential, only when that is so, then this term, as I told you a week or so ago, this term goes to 0 because k is positive as t goes to infinity. So this goes to 0 as t goes, and it doesn't matter what c is as t goes to infinity. This term stays some sort of function. And so this term is called the steady state or long-term solution, or it's called both, the long-term solution. And this, which disappears, gets smaller and smaller as time goes on, is therefore called the transient, because it disappears as the time increases to infinity. So this part uses the initial condition, uses the initial value, let's call it y of 0, assuming that you started the initial value at t when t was equal to 0, which is a common thing to do, although not, of course, not necessary. The starting value appears in this term. This one is just some function. Now, the general picture of the way that looks is the steady state solution will be some solution like, I don't know, like that, let's say. So that's the steady state solution, the SSS. What do the other guys look like? Well, the steady state solution has this starting point. Other solutions can have any of these other starting points. So in the beginning, they won't look like the steady state solution, but we know that as time goes on, they must approach it, because this term represents the difference between the solution and the steady state solution. So this term is going to 0, and therefore whatever these guys do to start out with, after a while, they must follow the steady state solution more and more closely. They must, in short, be asymptotic to it. So the solutions to any equation of that form will look like this. Even if they, up here, maybe it started at 127, that's okay. After a while, it's going to start approaching that green curve. Of course, they won't cross each other, but they're sort of like that's the rock star, and these are the groupies trying to get close to it. Now, but something follows from that picture, which is the steady state solution. What, in short, is so special about this green curve? All these other white solution curves have that same property, the same property that all the other white curves and the green curve too are trying to get close to them. In other words, there is nothing special about the green curve. It's just that they all want to get close to each other. And therefore, there isn't, though you can write a formula like this, there isn't one steady state solution, there are many. Now, this produces vagueness, you know, so you talk about the steady state solution, which are you talking about? And I have no answer to that. Whichever one, the usual answer is whichever one looks simplest. Normally, the one that will look simplest is the one where c is 0. But if this is a peculiar function, it might be that for some other value of c, you get an even simpler expression. So the steady state solution, about the best I can say is either integrate that, don't use an arbitrary constant and use what you get, or pick the simplest. Pick the value of c, which makes this, gives you the simplest answer. Pick the simplest function. And call that, that's what's usually called the steady state solution.